All right, so this is about difference of squares. Now I'm just gonna, they want you to do a little investigative process here to kind of start to formulate what's gonna happen. So previously we said, okay, what if you had in your charts, you've been doing these little charts right in your book, a product of negative 16 that gives you negative 6. So what are a couple numbers that multiply together to get 16? Jace, what would you choose? You would go with 8 and 2, because those numbers multiply together to get 16, and they can be combined in some way to get a 6. Now we got to put in our signs. So if we had a negative 8 and a positive 2, right? We're like, okay, so if this was the polynomial, our factored form would be x minus 8 and x plus 2. You agree? That would work? Okay, so let's just do a little bit more. What if it said, okay, we're going to get a 16 when you multiply them, but then we're going to try to get a 15. Start with your same product. Would you choose 15 and 1, did somebody say? Okay, 16, sorry. 16 and 1, those numbers multiply together to get 16. But if you had to owe 15 in the end, you would have to be negative 16 and a positive 1, correct? Okay, so your polynomial could be x squared minus 15x minus 16, and then the factored form would be x minus 16 and x plus 1. Okay. But what would happen if you needed numbers that multiplied together to get negative 16, but added together to get 0? Jace knows. Anybody else know? Okay, Jeffrey has his hand up next.
Yeah, it's 4 and 4.
4 and 4. Oh, so you mean if I had a 4 and a 4, I could get 16. And if I made one of them negative, I could get a 0 out of the deal. So what that would look like, I'm going to skip that, that's kind of confusing, is I would have the x squared, the middle term, the x term wouldn't exist. I would have a 0 of them, but the last term would be negative 16. And this turns out to be x minus 4 and x plus 4. Agreed? I guess I shouldn't scribble it out. Maybe that was useful. Could the same be done with 64? Are there numbers that multiply together to get 64 and combine to get, oh, there are. It's 8 and 8. Okay, I'm not going to finish over there. Well, my factored form would be x minus 8 and x plus 8. And, okay, this would be x squared minus 64. How about 25? 5 and 5, 5 and negative 5, and this would be x squared minus 25. The middle terms would give you 0. And then you'd have x minus 5 and x plus 5. Do you see a pattern going on? Now, what is special, just a minute, Kale, what is special about all these numbers? They're perfect squares. Are there other numbers that are perfect squares that we can put in that same list and come up with really quick? 49. 9, 4, 81, 100, 121, 144, 169, 196, 225. We could keep going, right? 254. 256. Yeah. Okay, now Kale, did you have a question?
Yeah. So if you have like the last two, minus 8 and then like plus 8, you couldn't go like x minus 8 squared, right?
Correct.
They have to be the same sign?
Yes. So Kale is clarifying that this is different than this. This is x minus 8. And you know what? I just had a kid in the grade 12 class mess this up right there. They took x minus 8 squared and said this is x minus 8 and x plus 8. No, it isn't. Squaring something is timesing it by itself. Agreed?
Yeah.
That's different. What I wrote up there. Good note. Okay, so we have this cool little thing that is called the difference of two squares. If this is a minus sign, and both of these are squares, and there is no middle term, see how there's no 7x in the middle? It's just going to be x minus 3 and x plus 3. I'll say it again. So Victor, Kale, if there is a subtraction sign, and both of these terms are perfect squares, it's the easiest thing you're going to do today. You're going to go like this, x minus 7 and x plus 7. There's no third term. The third terms are gone, right? Because they combine to give you 0. I will do one more and then I'll confirm. What do you suppose? Is this a subtraction sign? Yes. Are these perfect squares? Yes. So I can go to 2 brackets immediately and go x, and what are my other terms? 6 and -6. Does not matter which one is the plus and which one is the minus, as long as they're opposite. Now I'm going to prove to you that this works. Ready? Notice how there was no third term. We only had 2 terms. It was a difference of 2 terms, 2 squares. Okay, watch what happens if I do my check down here. I get x squared. Look at this. There's my plus 6x. There's my minus 6x. And there's my negative 36. See how the 2 middle terms went poof? And it works every time those things are true. There it goes, and you end up with x squared minus 36, which is what you had originally. And you're like, woohoo, this is great. Like this kind of factoring. So what do you think this answer is going to be? Quick.
X minus 1 x plus
Yeah. Next, over here.
a plus 10.
A plus 10 and a minus 10. Does not matter which one is negative, which one is positive. The x term that used to be in the trinomials is now gone, right? Okay. I'm not going to do part C, I just did it. Okay, part D. When I have x minus y and x plus y, can you explain why there is no middle term, why that's a 0? Can you explain why that happens?
Because when you add together 2 is opposite.
Okay, because you will be adding together, can I say combining? Because you will combine a negative value with the same positive value, right? Which equals 0, right? You know what I mean? You have a -6 and a +6, or a -18 and a +18, or -2 and a +2. That'll always give you 0. So then they say, okay, let's actually, if we did this, so those are the factors. What do we know is the answer to that? It's x squared what? Minus
Y squared.
y squared. So the value of c in this case, so c is y squared. Okay? Nice little difference of squares to factor to send you off in the rest of the day. Super simple. Okay? Let's just go practice it. So what they're saying is, as long as, now you guys, the difference of squares, those words all mean something. What does the difference mean in math? What is the difference? If I said, what is the difference means subtract? It has to be a subtraction. Do you know why? Because one has to be positive, one has to be negative, right? If they're both positive, they won't cancel those middle terms. Or if they're both negative, they won't cancel. So it must be the difference, and they both must be squares. If that happens, if you have a squared minus b squared, then the factoring is super simple. Okay, you get it? All right. Here we go. Factor the following using the difference of squares methods. Here we go. What is it going to be? Let's start with Victor back there. What's my answer?
A minus 4.
No?
Oh, would it be like 2?
Yes.
And then a and then plus 2.
Why did you choose 2 and not 4?
Because you have to like multiply the 2's.
Yes. Good. Kale, we're on this one. Go.
Same thing. So you go like t brackets and you minus. You do 14 or 11.
No.
Or
What's the square root of 144?
12.
12. So t minus 12, and then what will this one be, Kale?
That one would be. Could it be 12 again?
Yep, plus 12. Notice there is no middle t term to start with, right? So if one is a positive 12 and one is a negative 12, they will cancel each other. You understand how that works, Hannah? Yes? Okay, so Hannah, go here. Is this a difference of squares?
Yeah.
Yeah. All right, Hannah, start. Mhm. Perfect. Okay. Sariana, is this a difference of squares? Uh-huh. Go. Perfect. Yeah? Yes.
So what happens if it's a plus sign?
Doesn't
Like,
work.
that's only-
You will put M. Okay, let's do it. Right. You know what, Malcolm? I am so glad you asked. Thank you. Note that it is not possible to factor a sum of squares like x squared plus 4. You can't do it. Let's try. X squared plus 4, we would go, okay, x, and then you would go x, and how about 2 and 2, and how about they're just both positive? Can we do that? Let's go try. Let's see what happens. So this is my check. So I multiply it all out. X times x. Here comes a plus 2x. What happens next? Plus 2x. Okay, so part of this is good. I get my x squared. That's great. But I get this 4x term in the middle thing, so I have to combine those. See, they don't cancel. So then you have something that is not the same as the original and doesn't actually work. But good question. You can't do this quick process if there's, in fact, x squared plus 4 is not factorable at all.
That's just the lowest.
It's as low as it can go. We're done. Yeah. Okay? Okay, come down here. Factor if possible using the difference of squares method. Perfect. Is this the difference of 2 squares? Yes. Okay. Difference of squares is easy. One's a minus, one's a plus. What will be first? 4t. And then? Minus 7 and plus 7. Doesn't matter which one. Good. B. Somebody else. Kylie. 9a. Minus 1 plus 1. Good. Miss Genesis. C. Is it the difference of 2 squares? Yes. Go. Uh-huh. Excellent. Okay. D. Let's give you a minute to write it all down. Brooklyn. D.
6p minus 5
6p minus 5.
q.
Yep.
6p plus 5q.
Excellent work. Letter E. Joey.
Not possible.
Is this the difference of 2 squares?
No.
Well, it's got 2 squares. I've got 2 squares. What's the problem?
So,
There's a plus sign. That was easy. Not possible. Okay, Ben, you're on. Is this the difference of 2 squares?
Okay, wait. 8? Okay, wait.
Is it the difference of 2 squares?
Yeah.
Yeah. Okay, good. Hi, Jewel.
Hi.
Okay, go.
Difference of 2 squares. Okay, so 8.
8.
Minus.
Uh-huh.
9, because it doesn't divide by anything, right?
Oh, yeah. Does it have a square root? Remember, we're picking the square roots.
So if it's a square root and it divides by 2.
So if we go 3, no, you take the square root of it. So this is 8 and 8. Then we have 3 and 3. And then we have AB. Do you agree that 3AB times 3AB is 9? We're still breaking up 9 into 2 pieces that multiply together.
Oh, I get it.
Do you get it? We're still breaking up 9 into 2 pieces that multiply together to get that, right? Okay. Last one, and you can go to work on your own. The floor of an international double squash court is rectangular, meaning they're not the same length, but it has an area of 25a squared minus b squared square feet. This is so real life, isn't it?
Yeah.
This is what happens in real life. Okay, and it says write the expressions for the length and the width of the floor. We are given area. Area is created by multiplying the length times the width together. So I need 2 things that multiply together to give me 25 a squared minus b squared. Agreed? So that's just called factoring, by the way, people, right? When we break into things that multiply together. Okay, so here we go. We just happen to notice this is a special kind. Go, Malachi.
5a plus
Uh-huh.
and 5a minus.
Good. Now, are those the same lengths? No, one is shorter than the other because one is subtracting and one is adding, correct? Okay, so it makes sense that they would call this a rectangular floor, right? Pay attention to those words, they make a difference. Okay, now it says, okay, so this is my, let's call this one length. It's a good wink, good practice. And this is the width. Talented. Agreed? Would you call that length and width? I would call usually the longer one. I mean, provided that B is a positive number. But okay, then it says, hey, the perimeter of the floor is 140 feet. Tell me what you know. What's perimeter, Paige?
It's like the distance around.
To go all the way around. So I could draw a box. Okay, let's draw a box. I know this is 5A plus B. Then this would be 5A minus B, and I got to go all the way around and get 140. Is there, okay, so do you agree that then you would write 2 lengths and 2 W's is equal to 140? Agreed. Now, is there kind of a better way, an easier way? What are you thinking, Jeffrey?
That you can take it and divide 140 by 2 and only use the 2 sides.
Let's just go halfway around.
That's halfway around.
We could go all the way around to make 140, but that means halfway around is how far? 70. Wouldn't that be nicer to not have to have all these 2's involved? Wouldn't it be true then, that is what he's saying, okay, if that's true, then wouldn't it be true that 1 L and 1 width would be 70? I think that would be easier. You can do this if that's what you think of, but if you can think just one more step, that 1 L, do you understand what he's talking about?
Yeah.
Going all the way, okay. Going all, there we go. Going all the way around is 140. But if I just go halfway around, like here to here, there, that's a length and 1 width, and I just would cover 70. Agreed? That would be easier. Okay, so what is my L? 5A plus B. And I'm going to add, what's my width? 5A minus B, and I'm supposed to get 70 out of the deal. Okay. Go. What do you do now? What could we do?
2 brackets.
Well, that's not really the goal. I did my factoring up above. We're trying to find the length and the width of the floor. Just finish there. What could you do now? No. Couldn't I just combine that left-hand stuff together? Don't I just have plus and minus signs? Can we just group them together? Isn't it true that 5A and 5A on the same side is 10A? Yeah. And then plus B minus B is gone. Let's just do some algebra. Just combine some stuff together. And then you get equals 70. So what is A? Oh, well that's nice. So divide by 10, right? If you didn't catch that, divide both sides by 10. This is algebra back to 8th grade or 7th grade. You get A is 7. Okay. I'm trying to find the length and the width of the floor if the length is 1.8 times the width. But I just worked with the first equation I had and got A to be 7. Can I put that 7 somewhere now? How about I put it everywhere there's an A? So I have a new thought here that this is 5 times 7. Make that 35 plus B. And this is 35 minus B. Isn't that true so far? Like we're just finding one thing, putting it in, not getting all excited about the whole 1.8. Okay, we're just doing one thing at a time. So far, so good? Okay, now let's do the next sentence. Joey, I just did the first sentence. All of that came from the first sentence. Let's do the second sentence. Determine the length and the width of the floor if the length is 1.8 times the width. Give me an algebraic equation for those words. The length is 1.8 times the width. I've taught you this. You know what to do. Go, Jeffrey. L equals 1.8 times width. Don't you agree? Is means equals. Yeah. Remember? Maybe? All right. Let's just fill in what we have. What can we put in for L?
35 plus
Copy. What can I put in for width?
35
Oh, look at that. We have an equation, we got some work to do, but we're pretty set now. So work nice, won't it? What are we trying to do? We gotta find B. We're trying to find the length and the width of the floor. Like it's supposed to be like 17 to 12 or something, okay? So we gotta find the B. If you had B, wouldn't you be done? You'd put it right there and find the length. You'd find B, put it right there, put it in, find the width. So we just gotta find B. Do you have enough information now to find B? So what should we do first?
You put 1.8 into the bracket.
Yeah, let's go multiply that inside, right here. So we're gonna copy, don't be afraid to copy, it'll save your life. And we gotta multiply 1.8 by 35. What is that called when we put that in there? There's a mathematical word for that. Distribute, we're gonna distribute, use a distributive property and multiply that 1.8 times that. Okay, what do we get? I don't know. 60 what? 63. Don't forget, if you're distributing candy, you better hand it out to everybody, right? So this 1.8 must also be given or distributed or multiplied by negative b. Okay, so negative 1.8 b. And Abby's really good at this. What are you gonna do, Abby? That's a b. What are you gonna do?
Did you put the subtract the b from the left?
Sure, do you want to subtract b from both sides?
Yeah.
Absolutely, you can certainly do that. It's totally fine. Doesn't matter. Copy, you have 35 on this side. You've got 63 minus 2.8 b's. Everybody's good. There's a 1 there, right? So you owe $1.80 and you owe another $1, so you owe $2.80. Agreed, Miles? Okay, no, it's next.
I thought you got rid of the B though.
No, because you remember we're just subtract. So you owe $1.80, or let's say you owe 1.8 bubbles. So you balloons, and then you owe another balloon. So now you owe 2.8 balloons. Okay, I don't know. Just come up with something. Okay. So when you add and subtract, you're still just talking. You're just putting together and counting the pile, right? So you owe some, you owe some more. You still owe those things. You just happen to owe a bit more of those things. Okay. What's next? Quick, go, Jace.
Subtract 35 from 60, like from both sides.
Okay.
Or 63, sorry.
Oh, he wants to subtract 63. Okay. Minus 63 here and minus 63 here. Both sides of the equal sign, keep it balanced, right? So this becomes a 0. On the right, I have negative 2.8b, and on the left, negative, how much?
32.
It's 28.
I think it's 28. You would have to go 63, well, wow, minus 35, right? So it's negative 28, yeah. Okay, last step. Cece, you're trying to get b. Yep, divide by negative 2.8. And what is b? 10? I get 10. Is that my answer all done? I should quit now? No, what was the goal? Find the length and the width. Oh, right. So I've got my 10. I was close. Remember, I was back up here. I was getting there. So final answer, I'm going to say L equals 35 plus 10, which is 45, and width equals 35 minus 10, which is 25. Do not forget to give your final answer. 10 is not it. You weren't looking for B. You were using those to find it. Okay? Yeah? Okay, I've got one more thing to quickly show you. We have that written down. Super simple, and then we're done. You'll have 20 minutes to work on this homework. Okay? Okay, on the next page, on page 350, it says, what if there's a common factor? You should divide it out, remove it, right? So does this look like the difference of two squares? Not really. It's got a minus sign. There's two terms. I see a squared, but there's a problem. 2 is not a perfect square, and neither is 50. But is there a common term? Common factor? 2. So if we remove the 2, what you have left? Wait a minute. What step are we in right now?
1.
1. So how many sets of brackets should we have?
1.
1, good. And when you remove a 2, what will you have left? A squared, I heard it, minus,
25.
oh, look at there. You love those. Because these are easy. We love difference of squares. Now you go, okay, I'm not done. I should try again. Factor fully, right? Yeah? Good to go? Let's do one more. You pick one more. I don't care. C? All right. Is it a difference of squares? Just the way it is it a difference of squares?
No.
You mean 4 is not a difference of square?
Yeah.
Yeah, is 144?
People.
Yeah.
Yeah, it is a difference of squares. But is there a common factor?
Yeah.
Yeah, there is, but does 4 go into 144?
Yes, 36.
Oh, so even though this is a difference of squares, just the way it is, you still need to pull out the common factor. You still need to do it. I'll show you what happens if you don't, but let's divide it out, right? Or factor it out. So let's take out the 4. What do you have left? What step are we in?
1.
So how many sets of brackets should we have?
1.
Thank you. So we're going to have 36 p squared q squared take away what? Huh? Do I didn't put anything there?
1.
Yeah, you need to put a 1 there. Good call. If you don't put the 1 there, you can't get the 4 back. Now do you have a difference of squares?
Yeah.
Yes. So we do. Does 1 have a square root? Yeah, it's 1. 1 times 1 is 1. So now we'll go to 2 brackets. What will go in the first slot? 6pq and 6pq. What goes in the second spot? 1. And then 1's a plus and 1's a minus. Okay, before you go to work, I just want to show you what would have happened if you hadn't have done that. Because some of you aren't gonna. You're gonna forget. Watch what happens, because it's not wrong. You're just not done. So this is just watch. Okay, I need all eyes up here. Everybody. This will come up on your test, guaranteed. If you had not done that, like remove the common factor, you would have said 12p squared q squared minus 2. Agreed? Is that where some of you were going to go? Like, that's different squares. Sorry. It's just PQ. Good call. Thank you. And that looks messy. Let's change that. Okay. Then I would have said to you, nope, this isn't right. You have not factored fully. That was so 12 times 12, 144, 2 times 2. I don't get why. Do you see that there is a common factor left in both sets of brackets? To factor fully, it has to be as simple as it can be. There can be nothing left that's common inside. So you would have to continue on. What's common here?
4 and 2.
Say again, what's common here? What do you see between 12 and 2? What's common? 2. You would have to remove the 2 and leave yourself with 6pq minus 1. But is there something common here? There's nothing common between 12 and 2? What's common?
6.
No, 6 isn't common to 12 and 2. 2 is common, people. Okay, you quit. You quit thinking just like 2 seconds ago. Everybody stop thinking. Okay, wake up. Think one more time. What is common between 12 and 2? 2. You need to remove the common factor, leaving yourself 6pq plus 1. You see the common ground between this pink solution and this solution? Do you see it? What's the difference between here and here? Is there anything? The whole number. So do you know what they want you to do? They want you to take this is all multiplied together. They want you to take that 2 and that 2 and put it in the front. Okay. So it can be done. If you don't remember to pull out the common factor, if you just get excited and you see these 2 squares with a minus sign, you just go at it, you will have to factor further. It'll take you one more line if you don't pull the common factor out first. You with me? It can be done. Just when you're done factoring, you could never leave this line. Look up here. Look up here. Look up here. Don't ever leave me something like that. That is not factored fully. If there are common factors inside, you must divide out the common factors again. Understand? Okay, begin. You have about 15 minutes. Work fast. Mrs. Deja is here to help us because Mrs. Lynn's gone.